Welcome to Lab 5. Today we're going to be talking about recoding some more, as well as reliability. Before we get started, I want to talk a little bit about methodology. So we have been dealing a lot in this course so far with single items. We want to know about some variable. We have a single score for each individual. However, in a lot of research, this is not the way it works. Usually there are multiple items to get a better sense of the variable. We would ask people a number of different questions about their depression or their happiness or their health or their sleep style. And then using all of those items, we combine them into a composite score. Similar to how last week we were curious about happiness and sadness as two different variables that we could combine together to get well-being. This happens all the time. For instance, we might be interested in a variable such as neuroticism. We want to have some score that represents whether people have high or low neuroticism. And instead of just asking them one question about the neuroticism, we might ask them a series. In this case, we're going to ask them 8 questions about their neuroticism, and then average them together. Now, for methodological reasons, we have designed it so that it isn't just higher scores on each of these 8 items means more neuroticism, but instead some items, a higher score means more neuroticism, whereas others, higher scores mean less neuroticism. You can look at the table here where we have neuroticism 1 through 8, and you can see that some of the variables, a higher score of strongly agree, does indicate that they are more neurotic. They are more depressed. They can be tense, worried a lot, moody, nervous easily. Whereas for 3 of the other items, a higher score would be the opposite of neuroticism. In fact, a lower score equals more neuroticism. Now, because of this, if we were to average everyone's score together just as it currently is, it wouldn't accurately represent somebody's neuroticism score. The same people who report a 5 on the first item and a 1 on the second item, we would then average them together to get a 3. But that's not representative of the neuroticism of the individual. For this reason, we need to practice what we did last week of recoding. We're going to practice that now. To do this, open up Lab 5 Data 1. In this file, you will see 9 variables. The first is the subject number, which we always have in our data files. And the other 8 are the neuroticism variables, 1 through 8. As you'll see, these are each labeled with their description. So neuroticism 1 is depressed, all the way through neuroticism 8 gets nervous easily. And we can go to our data view, and we'll see that we have about 50 participants, 49 exactly, and we have all of the different scores. And again, if I just average them together, I could go to Transform, Compute. Maybe I want to get the mean of all of these, so I'll type in neuroticism equals the mean of Neuro 1, Neuro 2, Neuro 3, Neuro 4, Neuro 5, and Neuro 8. We can click OK. But as you see in this newly generated neuroticism score, most of these are around the middle. And that's again because sometimes the people who were scoring high on some variables scored low on others, and so they misbalance each other. So using what we learned last week about recoding, we're going to go ahead and do that. We're going to recode the ones that need to, which we recall was numbers 2, 5, and 7. So we'll go up to the transform, recode into different variables, just like we did. We'll take Neuro 2, Neuro 5, and neuroticism 7. We're going to give them new names. Here I'll call this with an underscore R to indicate it recoded. And I want to change the old and new values. So I want a 1 to become a 5, a 2 to become a 4, 3 would stay the same, 4 would become a 2, and 5 would become a 1. And click OK. Now we see that the system has generated these recoded variables. So now we can generate a new neuroticism score going to the same transform compute. But this time, instead of including the original variables, I'm going to include the originals of the ones I have not recoded, as well as change the ones that I have recoded. So for neuro 2, I'm going to put that underscore R. For 5, I'm going to put that underscore R, and for 7, I'm going to put that underscore R. As you see, these match up with the 3 that we have recoded. Now I have my new neuroticism. I'm just going to call this neuroticism R. And now we see our variables have changed. We're getting lower on some and higher on others, a little bit more dispersion. So this recoding before you combine the items is essential for proper methodology. Now, we might also be curious whether someone who scores as higher neuroticism on one item also scores higher neuroticism on others. So are increased scores on one associated with increased scores on the other? Now, we're going to do this through what's called a reliability analysis to generate what's known as a Cronbach's alpha. Now, you don't really need to get into the details of how this Cronbach's alpha is calculated, but what it's doing is finding, do increased scores on one item associate with increased scores on all the others, and then you do that for each item. So every combination of items that's possible, it's going to take a relationship and then average those relationships together. Now we calculate a Cronbach's alpha by going to Analyze, because we're trying to find out something about our data. We're going to go to Reliability, and then in this items box for a reliability analysis, we're going to put all of the ones that we want to know, do they hang together? So we might, before our recoding, have put together these 8 items. Let's imagine we had forgotten to recode. So we put these 8 items together, and it's important to note here, do not put the average item in. You are putting in the just individual items to see how they match together. We want it to get our alpha, a Cronbach's alpha, and that's really it. The only other thing we might decide is to show descriptives for the scale if the item is deleted. So if this one was not part of our list, what would happen? So let's see what happens there. Click OK. Here we go. We are going to get a number of scores in our set. And then here is the Cronbach's alpha. A Cronbach's alpha is on a range of -1 to 1, telling you how much do they hang together, with a 0 meaning they hang together 0 at all. There's no relationship between these different variables. And a 1 indicating there is perfect relationship. A positive number would mean that all higher scores are associated with the exact same higher score on others. A -1 would be every score is associated with a negative on another. In general, if you get a negative Cronbach's alpha, that's actually a bad sign, because it's indicating that higher scores on one variable are actually associated with lower scores on some of the others. Here's the number of items we have. So we could see here, looking in this last list, that if we had is depressed blue, if we deleted this, we would actually get a worse Cronbach's alpha. But for number 2, if we deleted this is relaxed, handles stress well, we would get a better Cronbach's alpha, closer to a 1. If we deleted this one, we would get a much worse, much worse Cronbach's alpha. But if we deleted number 5, we'd get a better one. And as you'll see, actually 2 and 5 and somewhat 7 all indicate if we deleted those ones, we would get a better reliability. So just for interest's sake, let's go and do that. Let's do Analyze, Reliability. Let's get rid of 2, 5, and 7, which, as you'll recall, are the ones we needed to recode. But we're going to do it with these 3, here with the 5 left over. And you'll see suddenly, once we get rid of the ones that were needing reverse coding, our Chromebox Alpha jumps high, much closer to a 1, which is our goal. In fact, a Chromebox Alpha of 0.8 is known as a cutoff that is appropriate, that if you are going to have items that you are going to average together, they should be at least a 0.8. So this is really good. By only using the same 5 items where a higher score equaled more neuroticism, and getting rid of the 3 items where a lower score equaled more neuroticism, it was reversed, we found a good reliability. But of course we don't want to stop there. We have done this recoding, so we now have that these 3 items, a higher score does equal more neuroticism, so let's put them into our reliability analysis. Let's go Analyze, Reliability, and this time we're going to put the Neuro 2 recoded, the 5 recoded, and the 7 recoded in. So we have all 8 where higher should be higher. Okay. And here we go. Look at our Chromebox Alpha now. It got even better. By recoding, by including those recoded items, we went from one where it was horrible because they were all going in different directions. Higher did not mean higher, lower did not mean lower on neuroticism. We took those out, we got better, and now when we included it, when we had 8 items, these are all hanging together much better at a 0.87. In fact, if you look at it now, you would see that only one item, if deleted, would make it anywhere close to better, and it honestly wouldn't even get better, it would get the same. This neuroticism 7, this remains calm in tense situations. So we're going to keep all 8 of these items together, and this tells us that the averaged item, that recoded neuroticism overall score that we have here, this is a good metric of neuroticism. Now, going back to our syntax and our output, you already know how to compute a score, and you know how to recode. So here we see in the recoding, we have that Neuro 2, Neuro 5, Neuro 7, and we're changing each one to be a different score into a new variable. Again, this should be review from Lab 4. You also know how to compute, where you have the goal, the new variable, equals some statistical formula. Here it's the mean of each of these variables separated by a comma. The mean of each of these variables separated by a comma. So this is the same syntax you've been doing so far. The only difference here, the only new thing, is this reliability analysis. For this Chromebox Alpha to generate it, you need to tell it to run the function reliability, then have the number of items or variables that you want to find how reliable are they together. Here we have 1 through 8. You want to tell it to get that Chromebox Alpha with the keyword alpha, and you get the total summary. That's what this item total statistics is about. So again, here we have that reliability. Variables equal all of those 5. Here we have reliability. The variables equal all 8, this time with the recoded. Again, asking for the alpha, the summary, and those are all of the items that you need. So that's actually it for today. What I'm going to do is give you a lab assignment where you're going to be given a similar scale, this time for self-esteem. You have to identify which items need to be recoded. You're going to recode those appropriately, average them together, find some descriptive statistics about each of the individual items and the overall item, and then generate a reliability score about this new self-esteem score. Best of luck.